Hey, g'day. Thanks for dropping by. It's Prezzo here, back in the shop. This is episode 5 of the Art Deco inspired Lixie digital clock. I've been working on this for a while. I'm actually making 2 of these clocks. In this episode, I'm going to show you 3 aspects of this design. The first one is to make a panel to close off this huge cavity in the back of the clock, and this is where a lot of the electronic devices will go, and also gives you access to the Lixie displays and the mounting hardware for those as well. We're also going to look at making a pair of feet which are screwed to the bottom of the clock carcass, and this just raises the whole clock case off the table and gives it a bit of definition and form. And the last thing we're going to look at is how I overcame my fear of doing this curved veneer surface on the end of the clock. This is the one that I left till last because I couldn't really figure out a way of doing it, and I'll show you the method that worked eventually after a lot of experimentation and failures. So let's get into the first part, which is making the back. So the ply that I'm using is a 3 ply. It's about 4mm thick, and it has to close off roughly that area. The problem is that it looks a bit chunky. It's sticks out a long way from the back of the clock there, and it's going to look particularly ugly at the bottom there. So what I wanted to be able to do is to rebate that to about half its thickness and then fit it inside this opening here. When I made the decision to rebate the edge of this plywood panel, I realised I could do this with a router, but it's very thin stock and it's a very wide cut. It was going to be a bit of a nuisance to hold it. And then I said, alright, well I can just run that past the saw blade and rebate it that way. But that in itself is a bit problematic. There's a gap beside your saw blade, and there's every chance that the stock's going to want to drop down into that gap. Now you could use a zero clearance insert, but I don't have one. Simple as that. So instead I am going to use this gadget here. Now I don't even know what this is called. I think it's called a vacuum pusher. And it's not my idea. I got this from a guy called Mirok. His YouTube channel is called Mirok's Woodshop. He made a version of this out of plywood. I've just worked with metal because that's what I like doing. And it's essentially just a square tube. There is a piston which you can draw up and down inside that tube, and that allows you to close off some of these holes from the vacuum. It's operated by a threaded rod, and there's a nut on the piston itself, and it's actuated by this hex-headed end on screw. And you can use a cordless drill with a nut driver to move that piston up and down inside the square tube. So what I've got at the moment is I've got all of these holes open up to this point here, and that suits the length of my stock. And there's a sacrificial PVC fence down here which engages on the end of your stock and allows you to push that through the saw blade. And if that ever gets chopped up and cut up, you just undo those 4 screws and put a new fence on it. So it works surprisingly well, very well in fact, and I'll just give you a demo. So I've got this attached to my shop vac, and you could use a vacuum cleaner, it doesn't really matter. And it's very, very impressive how much force is applied to that plywood. It's not easy to move it once it's in place. So I'll just show you what I mean. Now even without the fence to push that, just the vacuum alone is enough to hold that in contact with that square tube. So let's have a look now at how I did these cuts. This is just a scrap piece that I used as a trial. So there's my rebate in the plywood now, and that's going to fit into the back of the opening of the clock. It just gives me a slightly thinner profile on that edge there. What I've done there is I've just brought the piston back to that point there. So all of these holes are now blocked off from the vacuum, and it's only this group here that are going to suck the wood against that face there. So I can now turn the plywood sheet on its edge and rebate this section as well. There's the second one done. Setting that now to 16mm for the last cut that I have to do along the bottom edge of the plywood. Alright, so this is going to be the inside of that closure panel on the back of the clock. That's the outside there. I can veneer this in the Queensland walnut. To trim off this veneer around the edge of the rebate, I just went around with a little bullnose plane and just slowly skimmed that until it was able to fit inside that opening at the back of the clock. So arrange that so that it sort of almost snaps into place. And as you can see, it sort of only protrudes about 2, maybe 2.5mm from the bottom of the clock there. Now up here, that sharp corner is going to overhang the curve, so I'm going to cut that back to a radius of about 30, what is it? Radius of 18mm. So I'll just trim that off on the disc sander, and then we'll put some fixing holes in that. I'm not sure if you noticed, but when I was doing that, I didn't try and cut a curve, I just cut a series of straight lines which are tangent to the curve. And it's a little bit easier to judge when to stop. So instead of sweeping that around, you're just watching one point and you're stopping when the sanded edge reaches that line. So blending that now with the sanding block's really easy because you're just taking off a few little high points. Just take the sharp corners off those. Okay, I'll start marking out and drilling some holes here now. I'll be using these little nickel plated round head wood screws to hold the back on. I picked these up. A friend of mine was going to throw them all out. There was like boxes and boxes of them, and it's really hard to buy these now. So to mark out my centre lines for my drill holes, I'm just going to use a technique that I used to teach students for marking out lines for fixing nails and other fasteners. And if you're not terribly worried about absolute precision, this works really, really well. And the idea is that you open your hand, you rest the pencil across your index finger, you rest the point of the pencil, or at least the ground part of the pencil, on the middle finger, thumb in the centre, and it makes like a rigid unit. So just say, for example, you want to mark a centre line, say 12mm in from that edge. You just either mark it with a rule or estimate it, push the pencil point in until it's where you want it, and then with that locked against that middle finger, you just run your hand along that edge, just backwards and forwards like that. And it's surprising how accurate you can be with that. So once you've locked the pencil on your fingertip, as long as you don't move it, it's going to give you a consistent result. So I've already marked a point here about 7mm in from that edge. So I'm just going to mark that where I need it, which is in the middle, down this end. I want one up here, middle, and down there. I'll need to physically measure that distance there now to locate the center one. Other ones I can, once again, I could estimate them. So I'm going to do the same. I'll reset the pencil to that position there, come in from the end, there, that one. Now this one is a little bit different. By the way, you can also go around curves. Just take it in short little stretches, go around a curve like that. I'm going to place the other one about there. There's no real need to be terribly precise with this. Okay, got my 6 points, so I'll go and get all those drilled now. All I need to do now is transfer this existing hole from the back through to the body of the job. And the tool that I'm going to use for that is called a brad awl. We used to use these in school workshops because, well, basically if you give a kid anything like a cordless drill or a hand drill, they'll just break it. At least with these you can straighten them and resharpen them. And they're very, very simple to use, and they're good for softwoods, not so good for hardwoods. And the idea is you just place it through the existing hole and center it if you need to, and then you place the palm of your hand over the end of the brad awl, wrap your fingers and thumbs around it, and then get your elbow directly above your wrist and just press down and give it a few turns from side to side. And you can put the tip of that index finger where you want the depth to be, and when you feel that brush against the wood you can stop. So these little round head nickel plated screws, they look nice and retro, and they'll sort of make their own thread as you drive them in. Now the danger here is that if that screwdriver tip slips out of the slot in the screw, it's going to mar the veneer or dig a hole in it. So what I always suggest, especially for students, is you take a grip around the shank of the screwdriver between those two fingers, and then they help to keep the tip of the screwdriver centered over the head of the screw as you drive it in. And don't overdo it. And what they always suggest you do is to line up the slot with the grain of your wood, which is called heading the screws. The material I have for this is Malaysian teak, and it's as close as I'm going to get to Queensland walnut. And I think I said earlier in one of the episodes that solid Queensland walnut is now almost impossible to get. I think guitar makers use it, but in furniture grade sizes it's very hard to get. Now you can see here that these two pieces of teak have been taken from the same plank, and the grain lines up there, and there's also a little bit of sapwood on the back. So I don't want that to be visible at the front of the clock. So it's going to look something like that. So in order to keep the colour matched, I'll leave them in that arrangement. Now the drawing shows that I need to have a radius at this corner here, which is 40mm, and all the other radii on the front are 10, and the ones at the back are 4. So I'm going to use a radius template for all of the smaller ones, and I'll have to use a pair of dividers to get this radius 40. So I'm just going to mark these because I'm an old coot and I forget things. So I'm just going to put 40 there, 10 at the back, 10 there, 10, 10, and then these 3 are all going to be 4. Alrighty. Okay, now I already have my dividers set there, so I was just double checking that if you are setting a pair of dividers, these are spring dividers by the way, always set one of the points on the 100mm mark. Now the rule will have graduations which are engraved, and you can feel the tip of the divider fit into that engraved mark, and then just wind your divider to the dimension that you want. Now the idea of doing that is that if you try and start from the end of the rule, you can never be sure that the tip of the divider is tight against the end of the rule, and it might be a little bit away and the dimension you get is inaccurate. Similarly, if you start from the 10mm mark, you've got to remember to add the 10 onto the dimension you want. So in this case you'd have to go to 50. If you start from the 100mm mark, you don't have to do the maths in your head, and for me, not having to do maths is bliss. It's great. So that's what I always do. So here's my center here, here's my divider, and I'm just going to scribe that around, and I'm ready to go ahead and sand all of those curves. Now, I might just knock this one off with the bandsaw close to the line though. As I'm doing this one, I want you just to notice that I can do it basically in 3 straight cuts. So the first one about 45 degrees, second one about 30 degrees, third one 60, and that pretty much looks like a curve. So now it's just a matter of sweeping that around, just taking the high points off. And that is as close to a curve as you're going to get. For these small ones, you could basically just leave it like that with 3 cuts and then do it with a sanding block to finish. One of the last things to do on this now is put a 6mm radius all the way around the top edge, and I was going to use a little router for that. Well, there are the feet roughly in the right place, but what I need to do now is to set the overhang accurately. It's 10mm on the drawing, so what I'll do is I've got a piece of aluminium stock here which is 10mm thick, and I'm going to use that as my gauge to judge that offset accurately. It's a bit hard when you're trying to use a steel rule and you're working with a rounded edge, so a bit of square stock or rectangular stock is always easier. I'm going to be fixing these on with a nickel-plated countersunk head screw this time, and 4 for each foot, and that way I can remove these and I'll finish them separately and screw it all back together again later, and that way I won't have any sort of sharp corners in here where I can collect polish and it's easier to sand and so on. Okay, drilled and countersunk all the holes in the feet, and I've got these held on with a couple of spring clamps, and I've just gone around and just checked with my gauge piece on the ends and the face, and then finally I checked with a straight edge to make sure they were aligned. Even though you've done all of that, it's also a good idea just to do a visual check. Just have a look and just, ask yourself the question, does it look uniform? And if you're happy with it, then you can go ahead and start fixing screws. And even then, I would suggest that you just put, say, 2 screws diagonally opposite, double check it again, and if you're happy, put the rest of the screws in. So these are the screws, countersunk head with a slot and nickel plated. Once again, it's got that nice retro look about it. I don't think that, you know, Phillips head screws are going to look right in this. So I'm going to use the same method I'll use for Bradall, and just get a couple of screws in there before I am convinced that it's correct. If you are wanting to drive slotted head screws, or any type of screw for that matter, always get the longest possible screwdriver you can get your hands on. It gives you more control. If you go off center slightly at the top of the handle, it has far less effect at the tip of the screwdriver. And the technique for holding it is the same as what I showed you for the Bradall. That is, you put the tip of the handle in the palm of your hand, wrap your fingers and thumb around the screwdriver handle, and then stand the screwdriver up vertically, and you need to get your hand, your wrist and your elbow in one straight line, and then drop your shoulder slightly and put the weight down on the palm of your hand. That will keep the screwdriver engaged in the slot, in the screw, and then just turn, and there's less likelihood it's going to slip out. Okay, like I say, I'll put the rest of the screws in later. I just want to be sure that this is correct before I go any further. That looks right to me, but I'm not going to do it now. I'll get everything sanded and I'll get it all finished, and I'll put all the screws in later. Okay, well, I feel like I've been here before, but I'm about to explore yet another method for wrapping this veneer and bonding it down to this curve. And as you would have seen in the last installment of this saga, I had high hopes for the method of using a flexible rubber caul, but it turned out that that didn't work. I did manage to recover that piece of veneer and get it to bond down tight. So this is the last one that I need to do now, and the technique that I'm going to use involves using this flexible rubber caul. This is not a stretchy rubber, this is just a sort of a soft cushioning type rubber, and I think it's called EVA foam, but I can't be sure about that. And in order to get pressure on that, I'm going to use this material. This is a laser engraving plastic. It's quite thin, only about 1 millimeter. It's sufficiently flexible to go around that curve, but it's stiff enough to put really good pressure on that foam and the veneer underneath. So I'm sort of hoping that that's going to work. I've tried it once again, tried to dry, it looks okay. So we'll see how we go. And you're probably saying, oh, for heaven's sake, just go and buy a vacuum bag and do it that way. And I have got a vacuum pump, and I've done vacuum bagging before, but I don't know, it just seemed a bit awkward. It's sort of fairly deep, it's got a fairly tight curve. I was worried about it buckling in here, and you know, it just seemed like an awkward shape to do. And like this whole job, there's nothing about it that's straightforward. Anyway, let's get this method a go and see how it works out. And the most important thing is I'm learning stuff. You know, even if I learn how not to do it, that's probably a good thing. Let's go. Okay, well, I've got everything sort of glued and sandwiched there. These two clamps here are just to press down the joint between the already fixed piece of veneer and the new piece that I'm putting on. And there's the correct layering of all the sandwiches. So I'm just going to turn this around so you can see as I close this. And let's hope this one works. So I'm not sure if you can see that, but the glue's evenly spread in there. And as I pull that plastic down, it's sort of got no choice but to compress that piece of foam rubber in there. If we'll put a block over here and a couple of clamps on the inside, that should work. Like famous last words. Okay, I'm not sure if you can see in there, but that looks like the glue's squeezing out all the way around that joint. And from what I can tell, the veneer has bonded completely. There are no gaps there that I can see. However, having said that, it looked the same before when I was using the stretchy rubber caul, and I came back sometime later and it had come apart and there was gaps there. Honestly, I can't see how this can fail. What do you reckon? Okay, well, here we are an hour later. Let's just see if I've had any success. Now you might be wondering what this is, and despite my earlier confidence, it did slightly go gappy on those corners there, so I just jammed a bit of veneer in there. But I think it feels good. So I think you can see in there it's closed up pretty good. There's the other one. But man, this is the most difficult thing to get that to go and conform to that shape, and you'd think it would be fairly straightforward. That joint there is good. That'll sand off quite okay. It's sort of tight in there as well, so that's good. I'll just trim that out with a knife. And I'll get this trimmed off and we'll just see how that comes out when it's all sanded. Well, there's that one sanded smooth, and it's tight all the way around. No sign of any gap there, but like I said, I did have to jam a bit of veneer into the gap between the plastic and the foam and the veneer. So I could see there was a tiny little air gap opening up there, but that's come out okay. Alright, that's good down there. Let's do this top one. Of course, this is the one that's most visible. Well, there it is. Now it's closed up really good. Well, there we are. We sort of got there in the end. So here are the three things that I said I was going to cover in this video. We've got the veneer wrapped right around the end of the clock carcass there now, and that's bonded down. I've checked it, there are no gaps, no voids, no loose veneer. So that was a bit of a bonus really. And considering the number of false starts and screw-ups that I made, this has turned out better than it had any right to really. So I'm grateful for that. Also got the feet attached, and we've got the plywood back with its veneer attached, screwed to the back of the carcass. So that's what it's looking like at this stage. And I think that when the Lixie panels go in here and we're seeing the nice bright LEDs against that darkish background, it's going to look really vibrant, it's going to come to life. So I'm going to finish the video here now. In the next episode we're going to have a look at the decoration. So that's going to be fitting the brass bezel around the inside of that opening. It's going to be fabricated from brass angle and some smaller pieces of flat brass, silver soldered together. And then we're going to have a look at hopefully nickel plating that. So would you like a little sneak preview? Okay, I don't know about you, but I'm really looking forward to seeing this finished. It's got everything I like. Beautiful rich tones of lovely wood, shiny brass, and some colourful flickering lights. I mean, what's not to like? It really does make an old nerd like me want to jump for joy. Oh, my knee!